Hi, I'm Bob Craycraft from the University of New Hampshire Center for Freshwater Biology. I'm the lab manager here, and we're going to continue looking at the phosphorus analytical procedure, this being part 3 of Continuum. And what we have done is effectively prepared some phosphorus samples that are in these 2 flasks sitting before you. They have basically gotten some preliminary workup and then been put into a pressure cooker, which you may have viewed previously. They're now cooled to room temperature, and they're ready for continued processing. And now what we're going to do is a couple of things. Effectively, we have converted all the phosphorus in these samples into one form that we can analyze. And at this point, we have to neutralize these samples. They're fairly acidic right now. And before we can actually perform the final preparation step, we're going to have to bring the pH down to neutrality. Right now they're far too acidic. So to do that, what we have is some sodium hydroxide solution sitting behind the flasks. And I'm going to take a repeating pipette, and from here we're going to pick up a known volume of solution, of base solution, this being again sodium hydroxide. And we're going to dispense it in each of these flasks. Again, we talked a little bit about the phosphorus being limiting in freshwater systems, and we have to use extreme care in this preparation procedure because our bodies are loaded with phosphorus, so we always use very clean pipette tips and glassware. But the bottom line now, in terms of what we're doing, is we've neutralized these samples with sodium hydroxide, so I'm going to swirl them around to complete that. If we had more flasks prepared, we'd go through this process repeatedly until all flasks had been neutralized. But for the purpose of this, we're demoing it, so we'll go to the next step. So these are now neutralized. Now we're going to take another reagent, and this is a reagent that's going to react with phosphorus. It appears yellow to the naked eye. But this is going to react with the phosphorus, and proportional to the amount of phosphorus in these samples, the water in these flasks is going to turn blue. So the bluer the flask, the water in the flask, the more phosphorus there is. Typically, this reaction, we let it proceed for about 30 minutes. So we'll go ahead and zap these with our reagent. And we're going to use a repeating pipette. Oops, I didn't dispense that properly, so let me redo that, because we want this to be as accurate as possible in terms of the volume we're dispensing, which in this case happens to be 8 milliliters. So we'll take our sample, and this is a repeating pipetter, so simply enough, we give one dispensing here to flask 1, one dispensing to flask 2, and we continue on if we had additional flasks. And we'd swirl these around, like so, and then we're going to wait 30 minutes for the reaction to complete. And I do have a couple of flasks I'm going to just lay out here next to this that were prepared about an hour ago, but this gives you some perspective on some of the variation in coloration between what we're seeing with our new samples and what happens when you have a little bit more phosphorus in there and let it react for an appropriate amount of time. And here's 2 more samples that were hit with that reagent about an hour ago as well. You can see there's a tremendous difference between the ones on the left and the 2 on the left and the 2 on the right. And what that tends to indicate is there's much less phosphorus in these samples on the left than those on the right. And our next step is going to be to go over to a spectrophotometer, an analytical piece of instrumentation that can pick up subtle variations in the color of this water, which will, again, give us an indication how much nutrient, in this case phosphorus, there is in the water samples.